Welcome back to our GATE preparation series. Today, we will be diving into the concept of virtual memory. This is a crucial memory management techniques that allows systems to run programs larger than the physical memory available. Understanding virtual memory is essential for both theoretical and practical purpose in operating system. Let's get started. Let's see what is virtual memory. Virtual memory is a technique that creates the illusion of a large memory space by using both physical memory means RAM and disk space. It allows processes to run even if they don't fit entirely into the physical memory by swapping parts of the process between RAM and disks when needed. Next, why do we need virtual memory? Imagine running a program that's larger than your available physical memory. Without virtual memory, the system would either crash or refuse to run the program. With virtual memory, the operating system manages memory dynamically, loading only the necessary parts into RAM while keeping the rest on the disk. This technique enables multitasking and running larger applications efficiently. Let's see paging. Paging plays a crucial role in virtual memory management. Pages from the process are sorted on the disk, and the operating system swaps these pages in and out of the physical memory as needed. This is known as demand paging. When a page is brought into memory only when it's required, the page table keeps track of whether a page is in the memory or on the disk. When the memory full and new page need to be loaded, the system has to decide which page to replace. Some common page replacement algorithms includes FIFO means first in first out. The oldest page is replaced. LRU means least recently used. The page that has not been used for the longest time is replaced. And optimal. The page that would not be used for the longest time in the future is replaced. Each of these algorithms has its strengths and weaknesses, and the choice of algorithm can significantly impact system performance. Let's see thrashing in virtual memory. Thrashing occurs when the system spends more time swapping pages in and out of the memory than actually executing processes. This usually happens when there's not enough physical memory to support the active processes and the system is overloaded with page faults. Understanding thrashing is critical to preventing performance degradation. Let's see the advantages and disadvantages of virtual memory. What are the advantages? It allows program to execute the physical memory side, supports multitasking by isolating processes from each other, improves memory utilizations and system stability. Let's see the disadvantages. It can lead to increased overhead due to page management. Thrashing can significantly degrade performance, require more complex memory management techniques. That wraps up our discussion on virtual memory. If you found this video helpful, be sure to like the video to show your support. Subscribe to the channel for more GATE preparation content. Comment below with any questions or topics you would like us to cover next. In the next video, we will explore page replacement algorithm in more detail. So stay tuned. Keep learning and together we will crack the GATE. Thanks for watching. Now that you have a solid understanding of virtual memory, you are better equipped to handle memory management questions in GATE. Next up, we will be dive deeper into page replacement algorithm and their practical applications. Until next time, keep practicing and stay motivated.